Lesson 5, equations from graphs. So there's two ways that you can write an equation for a graph. The first way is to write it in factored form. And factored form looks like this. And this is where x1 and x2 are your x-intercepts. So for our graph, we have x-intercepts here and here. So we know x1 is negative 1.5. We know x2 is negative 0.5. Now, we cannot figure out our stretch just by looking at the graph. But what we can do is we can choose a point on the graph, any point. So I'm going to choose this one right here because it's right in the middle of the lines. And you can plug this point in as x and y so that all you're left with is your a value. So instead of writing x, we're going to write negative 1, and instead of writing y, we're going to write 0.5. So we're going to plug all of that into our equation. So we have 0.5 is equal to a. Our x is negative 1 minus negative 1.5 times x minus negative 0.5. And now we're going to simplify and solve for a. So inside the brackets, this turns into negative 1 plus 1.5 and negative 1 plus 0.5. What that turns into is plus 0.5 and times negative 0.5. 0.5 times negative 0.5 is negative 0.25. Divide by negative 0.25, and you get negative 2 to equal a. So now we know our equation could be y equals negative 2, x plus 1.5, and x plus 0.5. And we want to rewrite it because we want it to be for any x and for any y. If we wanted to put this into general form or standard form, we need to get rid of the brackets. So we'd have x squared plus 0.5x plus 1.5x plus 0.75. And the whole thing's times by negative 2. So we're left with negative 2x squared. 0.5 plus 1.5 is 2 times negative 2 is negative 4x. And 0.75 times negative 2 is negative 1.5. So this is our equation in general form. We can also find an equation in graphing form, which is ax minus p squared plus q, where p and q are our vertex. So the other one's useful if you have your x-intercepts. This one's useful when you have a vertex. So our vertex here is at negative 1 and 0.5. So our p is negative 1 and our q is 0.5. And because we don't know a, we want to choose a point on the graph, so we can use this point at negative, let's use the other one, negative 1, or negative 0.5, and 0. So we can use this point instead of x and y. So x is negative 0.5, and y is 0. So we're going to plug that into the equation. So 0 is equal to a, negative 0.5, minus a minus is plus 1 squared, plus 0.5. So remember, when you put this into here, we'd have minus negative 1. That turns into a positive. So we have 0 is equal to a, 0.5 squared plus 0.5, minus 0.5 to the other side, We have negative 0.5 is equal to 0.25a. Divide by 0.25, and you get negative 2 is equal to a. So our equation would be y is equal to negative 2 x plus 1 squared plus 0.5. And again, if you wanted to put this into general form, you would expand out your brackets. So you'd have x plus 1 times x plus 1 times 2 plus 0.5. So this would be negative 2 times x squared plus 2x plus 1, which is negative 2x squared minus 4x times negative 1 is negative 2 times 1 is negative 2, plus 0.5 is minus 1.5. So you get the exact same answer for your equation. It doesn't matter which way you do it. If you have the x-intercepts, it's easier to do the x-intercepts. If you have a vertex, you can do a vertex. Just know that all you need is a point and either the vertex or the x-intercepts. So if your x-intercepts were somewhere in the middle and you had to guess, try to do the vertex one.